All right, so in this video, what we're going to do is we're going to be taking a look at how we're going to work with Excel files, specifically CSV files, and make them interact with MATLAB, both reading and writing. So as an example I put together, let's say that we have a file, data1 CSV, and we have three columns of continuous data, height, weight, and GPA of male students. And what we want to do is develop some MATLAB code that's going to read the data and store it into a variable. And then we're going to find the mean and standard deviation of each list. And then we're going to create a scatter plot of the height versus the weight. All right, so once again, just like we did with the text data, we have the file that we're looking to import into the MATLAB program stored into the current folder. So again, you can drag that and put it in there. Start out with CLC and clear all. All right, and that way we're set to be able to work with this. And I'm also going to use close all. So that way, if there were some files open from a previous execution, that we can just utilize the same program without having to develop a new file or anything like that. All right. So first of all, I'm going to store everything into a variable. So I'm going to say A is going to be equal to, well, first of all, what I'm going to do is I'm going to CSV read. And I'm going to CSV read, and I'm going to enter the file name. So in this case, the file name is our data1.csv. And then I'm just going to go ahead and execute this. And notice what happens is in A, we have a slew of data, right? So, and remember we have the height, inches, weight, pounds, and then the GPA of the male students. So that was really easy to store into our variable A, right? Now we can just go ahead and perform the functions necessary, right? So for instance, in this case, we want to find the mean and standard deviation of each list. So we're going to find the mean of A, and it's going to be the first column. Okay, so we have first row, and, or I'm sorry, the entire row of the first element, or the first element in each of the column. All right, and I'm just going to execute that. All right, and that gives us 68.23. So again, what this does is it takes all elements in the first column and it finds the mean. All right, standard deviation. I remember last time it says STD for standard deviation. So let's try that. So we're going to try STD. Sorry. So I'm going to try STD of this. Let's see if it works. So this time it actually works. You might remember in the previous video, we couldn't get standard deviation to work. So that's the mean of the first list. And then we could do the exact same thing, except for the second and third list. So I'm just going to change these to 2s and 3. And that's going to find the mean and the standard deviation for each of the different groups. So the average GPA was 2.684. The average weight was 191.12. All right, and then the standard deviation was 23. We could do an printf to format it really nicely. Right? The other thing it was asked to do was to be able to create a scatter plot to show the relationship between the heights and the weights. Right? So I'm going to plot, and I'm just going to copy one of these to make it really easy on myself. So I'm going to do a plot of the first column in A and the second column in A as ordered pairs. And we're going to use the O to be able to do that. So I'm going to run this. I'm going to have to share the screen to show you what it looks like. So I'm going to go ahead and switch this out. And if you give it a minute, it'll come up. Might have to try it again. I'm not sure what happened. All right, but there it is. All right. And our scatter plot looks extremely linear, which we would expect for height versus weight. It's a pretty linear relationship, or it's a very strong linear relationship for most males. All right. So that's how we can read in from an Excel file to be able to work with it. Now, what about writing? Okay, so we have another example. And in this example, we have a function, T of T, which models the outside temperature during the day, the hours since midnight, and T is the temperature in degrees Fahrenheit. We're going to create a program to use the model to be able to find the temperature every 15 minutes throughout the day. And we're going to write that to a CSV file. And then I'll show you what to do with that CSV file. So we are going to create a scatter plot as well. So here's what we're going to do. So I'm going to clear all this out. Get rid of all this stuff. All right. So first thing we need to do is we need to make sure that we can write to the file. Okay, so the only command that we're going to do is this CSV write. All right, so I'm going to go ahead and start to prep this. So let's let T be equal to 0 in increments of every quarter. So 15 minutes, there's 4 15-minute intervals in an hour. So we're going to say from 0 to 0.25. Up to 24, since there's 24 hours in a day. So that's going to give us 96 unique observations for T. Now we're going to go ahead and figure out what the function evaluate that is. So I'm just going to call that capital T, and capital T is going to be equal to 80 minus the cosine, or 16 cosines, of pi over 12 times T minus 4. We shouldn't need any periods in there, right? So now we have a relationship of T and T, and now what we could do is plot that to see the relationship. Now we know it's going to be a sinusoidal relationship, so let's plot T lowercase versus T uppercase, and we're going to use our good old O. I'm going to run this, and let me share this with you so that way you can see what we're actually looking at. And not surprisingly, we get a really nice sinusoidal relationship, right? We don't know what the values are because we suppress them. If we did unsuppress them, then it would look probably not too nice because we didn't format it. So I can go ahead and execute it. And this is what our values of T look like. Again, not all that pretty. All right. However, what we'd like to do is we'd like to be able to write that into an Excel file called temperature CSV. Right? So I'm going to suppress this once again. And we do have the plot. And what I'd like to do before that is I'd like to assign those. Now notice what these are written as. These are written as a row matrix. And we don't want a row matrix for Excel. We'd like a column matrix. So check this out. This is a really easy way to get over that. Let's say T is equal to T prime, right? And what T prime is the transpose of T. Right? So that's nice. We could do the same thing with capital T. So now these are column matrices or column vectors instead of row vectors. And it makes it really easy to write those into Excel. One other thing that we can do that's really nice is we can just say X is going to be equal to another matrix, T and T. So that's really cool because now X contains one column of lowercase t, one column of uppercase t. Right? And now the only thing that we can do is just write it to the CSV file. So I'm going to say CSV write, and we're going to call it temperature. .csv, and in that file we're going to take everything that's in X right now and write it. All right. Now I'm going to go ahead and execute this. So there's our execution, all right? Notice that now, even though it wasn't there before, there's this temperature CSV, so that's a good thing. Okay. Now I'm going to open this and I'm going to show you what it looks like. I'm going to open outside of MATLAB, and then I'm going to have to switch the screen so that way you can see what it looks like. All right, so I'm going to change my screen to this temperature file, and now we're in the temperature file, all right? And notice that in one column, these are all the times since, and that's all the times since midnight, and these are the temperatures. If you want to in Excel, we can just go ahead and create the same scatter plot. So we can just highlight these, go to insert, and then we can go ahead and use the scatter plot option. And not surprisingly, we get the same sinusoidal relationship, all right? The difference is that most people are a little bit better with Excel, being able to utilize some of the commands because it's not a programming language necessarily. It's more of an application. So probably one of the more beneficial sorts of things. And we can make a lot nicer charts and edit those much more easily than we can in MATLAB. All right, so I think that's all that was asked for us to do. So write the code in an Excel file. Okay, so hopefully this is something that could be helpful to be able to take this sort of information that you can generate in MATLAB and export it into a CSV file. And as you know, you could probably just save it as an Excel file if you wanted to try to do something else. But the nice thing is CSV files can pretty much do everything that Excel or XLE or XSLS files can do, whatever the newer version of Excel is. So I'll stop here. And in our next video, we're going to be taking a look at 3D graphing.